Thank you very much. Welcome to the second day of the Digital Green Conference here in Berlin, and welcome all the people who are joining us online. We had a really very inspiring first day of the conference yesterday, and I'm really curious to know about all the projects which are presented today at the second day. I would like to introduce myself short because some might be new online here joining the conference. I'm Julia Wissmann. I'm a science journalist and currently I'm hosting a podcast called Science and Politics in Conversation, Wissenschaft und Politik im Gespräch from the Helmholtz Center Potsdam Research Institute for Sustainability. And it deals with sustainability, for example, digitalization and sustainability. Our main issue today is circular economy. Due to the resource scarcity, recycling and circular economy, I think, is mandatory. And I think it should be easy because we have a good role model. Nature is based on circular processes. To be honest, my favorite place, not only on Earth, but in my garden, is my compost heap, because I think it's magic, it's summer magic. Leftovers that we call garbage turn into fertile soil. Microbes decompose these leftovers within 2 weeks or something like that. And the smell, I think, is really good of a compost heap. So what can we learn from nature? That should be also a very important question probably today. And how can we use digitalization for more recycling and resource efficiency? So please welcome our chair for this third session with a warm applause. Dr. Adriana Nelligan has been working for the German Economy Institute in Berlin since 2004. So welcome, Dr. Nelligan. She has been a senior economist for environment, circular economy and sustainability since 2014. From 2004 to 2014, she was a senior researcher at IW Consult. She studied economics at the universities of Augsburg and Valladolid. And where is it? In Spain, of course, and completed her doctorate at Trinity College, Dublin. So thank you for being here and being the chair and giving us a little keynote concerning circular economy. You work as an economic researcher at the interface between science and practice. Looking at circular economy in Germany, where are we positioned at the moment?
Well, a couple of years ago when I started to look into the circular economy issue, I was one of the first ones here in Germany. That was in 2017. Before that, we only looked into waste management, and now we started, well, at this point we started to look at the entire circular economy, starting from design and what can we do after the end of life cycle. So basically that's where it started, where it came from, and nowadays it's on the political agenda. And I was at an event yesterday, that's why I couldn't be here, and at this event there were representatives from the Chancellery Office, there was a representative from the Environmental Office, Environmental Ministry, and the Ministry of Economic Affairs. So it is, and it is also here an issue. So all ministries are looking at this age, and it's on the main agenda, and there's a national strategy that is supposed to go through cabinet at the beginning of December. So we're not just looking at a niche.
Okay. The National Circular Economy Strategy. Yeah. So we cross the fingers that our minority government is passing it.
Well, they told us yesterday that it was going
really?
to pass. Yeah.
Oh, that's good news. That's very good. And we have an election date since yesterday. Yeah. So, there's hope.
Well, there is hope, and I'm sure there are a couple of people here who also took place in the stakeholder process on the way to the national strategy. So, I hope this is going to come through.
And you mentioned the eco-design directive, for example. Do you think something like that is the step into the right direction?
Yeah, I think we have to start at the design. I'm going to show in my presentation now how important it is to go towards eco-design, because if we don't have the right features in the product, we can't do anything with it afterwards. Like, we have to be able to repair it, to recycle it, to reuse it, etc.
And then you present 4 really interesting projects. Can you tell us a little bit what they aim for?
Well, we've undertaken a couple of surveys, company surveys, and looking at the issue of resource efficiency and circular economy in the context of how can digital tools, how can the digital product passport help to enable circular economy.
Okay, so thank you very much. So your speech now is from Dr. Adriana Nelligan from the German Economic Institute. The stage is yours.
Thanks. So as I was introduced so broadly now, I'm just going to start straight off. So what I'm going to show you now is a couple of snapshots from our surveys, and just to give you an idea what is the status quo in the German economy. And I'm an economist, so I'm always looking at the potential and the ways on how we can do this in a realistic way, and how we can actually get circular business models starting. So at the end of the day, there is still a lot of potential for saving resources, as there's by no means is the potential exhausted. So in a survey we undertook for the German Ministry for Economic Affairs, it showed that every second company believes that it could release further potential if it made optimal use of the technical possibilities. So digitalization could be an important lever at this point. So we asked the companies, that's what you see here on the left, that what savings they were able to undertake in the manufacturing sector over the past 5 years. And in the past 5 years, companies were able to save 6% of their material and 9% of their energy consumption. They were able to make energy savings of 6%, of around 9%. The small 1% shows the contribution of digitalization. We asked the companies in a further question, what was the contribution of digitalization? And that was only 1%. So there's definitely upward potential here to use digital tools more when it comes to optimize or to save material and energy. We also asked the companies whether they saw further potential. So every second company said they see further potential. In a further question, we asked them, how high do you think is this further potential? And in the manufacturing sector, they told us that there is a further average reduction of 8% that could be realized. So we used this data, and based on the available data on resource consumption in Germany, we could actually calculate a figure which is 10 billion euro, which is around 1% of industrial gross value added. Doesn't sound high, but it is. There is a potential that can be actually still used to save more material and energy. So at the end of the day, this graph looks a bit complicated, but I'm going to lead you through this graph. So at the first, digitalization and resource efficiency go hand in hand. So what happens if we digitalize and if we have data? That makes resource efficiency measurable and potential savings, as I just showed, actually realizable. So successful material saving companies see the benefits of digitalization for resource efficiency from the very beginning. So what this graph shows, and that is kind of, you can see the beige points, and that shows the share of companies that have a high material saving, and it is according to their level of digitalization when it comes to resource efficiency measures, because we had this project on resource efficiency and the role of digitalization as an enabler. So we actually looked at this specific question, and the higher digitalized a company is when it comes to resource efficiency measures, the better they can actually save their material. Yet, even though there are pioneers in saving materials, are also very often pioneers in digitalization, there's still only a few companies that are highly digitalized with many resource efficiency measures. So when it comes to the level of digitalization, we looked at different resource efficiency measures. It is mostly for optimization measures that, like optimizing processes, optimizing energy consumption, etc., that we can actually see high levels of digitalization yet. When it comes to circular economy measures that are a bit more complicated, that needs interaction with other firms, etc., the level of digitalization is much lower. So we already talked about eco-design and the eco-design directive and the national economy strategy. I'm not going to go into deep detail with this graph, but I just wanted to show where we come from. We've had an eco-design directive for many years, which was relevant for energy consumption. But now, with the EU Green Deal and the Circular Economy Action Plan, the European Commission started a whole new kind of initiative, the Sustainable Product Initiative. So with this, we've got a new directive, which is the EU Eco-Design Directive, that also includes a digital product passport. So what does this mean for us? So resource saving, durable, repairable, and energy efficient products are now becoming the norm in Europe. And how do we get there? That's the big question now. So many of the projects that are being presented here are part of this process and how we can actually get to this point. So because we have new requirements now, the EU Eco-Design Regulator lays down new requirements for most products, that they have to be durable, that they have to be reusable, upgradable, and repairable. And as there are only a few exceptions, it does apply to basically every firm in Germany, in Europe. So it has always also been decided that we have a digital product passport because we need more transparency. If we want to look at the entire product life cycle, we need information at every point. So this is still being discussed. It has been decided, but the actual implementation is unclear yet. There are certain technical requirements, and there are also ideas on the content-related requirements, but it is still an idea that has to be implemented. So where does the German economy or where does German industry stand when it comes to this issue? Looking at the circular economy readiness first, well, in one survey which we undertook last year, we asked the companies, what are important product features for your product? And what this graph shows is we asked them all the different product features that are relevant for the Eco-Design Directive. At the end of the day, I'm sure when it comes to the delegated acts for each product group, they might not have to fulfill all requirements, but just to have a snapshot, an idea on where companies stand, we asked them all of them. And what it shows is that some relevant product characteristics like durability, longevity, etc., are already strongly developed. This doesn't surprise. This is a classical characteristic of the Made in Germany quality promise. So, but when it comes to repairability, recyclability, reusability, all these issues that are being discussed now in the political context as a real circular economy, there is still more potential here. So it hasn't been in the center of focus in industry yet. But there are a lot of discussions beyond the survey on this issue. So I think the idea of the circular economy still needs to be implemented more as the idea we have to start from design and not only look at the end of the product life cycle, what we do with the materials that are left over. This is also important, but we need to broaden the whole context. So most of you, I'm not sure whether everybody is familiar with the Digital Product Passport. What is the Digital Product Passport? It should include information about the product, such as the manufacturer, the material, characteristics, repair, and disposal options. And what happens is, these are all content related, but it also has to fulfill technical requirements. When we come to the content related information, a digital product passport needs a unique identification because we are talking about millions and billions of products. We need a precise description of the product and its characteristics, and we also need all the relevant, environmentally relevant information for producers, for suppliers, and for consumers. So what this graph shows is we start off with the resources, and they send the resource suppliers sent data on the production. Where was it? Where does it come from, where was it extracted, etc. Then the manufacturer has all this information and can actually receive the raw material information. And then it sends, after manufacturing, the information into this. So if we go on, retail, consumer, repair, facility, waste management, the entire product life cycle receives or sends information. This is an ideal world. I absolutely support this idea that we need more transparency. But if you think about the products that we actually produce here in Germany, where we have a lot of intermediate products, we've written a paper on the Digital Product Passport, and I haven't brought this picture, but at the end of the day, we used an analogy of a train. So you have a train, and then all the suppliers bring in their digital product passports for the intermediate goods, and the train gets longer and longer and longer. And what happens with all this information at the end of the day? If somebody is repairing this product, or if something is being taken out when it was remanufactured. So there are a lot of issues. So just to show you the complexity of a digital product passport, it's a very good idea, but it needs to have a realizable solution at this point. So just having explained the digital product passport and how complicated it is, I would like to point out where we stand here in Germany when it comes to data economy readiness. If we want to implement a digital product passport, we need to be able to receive and send data to other companies, etc. We need to digitally store data. We need to manage data, and we need to be able to analyze data. So my colleagues regularly undertake a data economy readiness study where they actually ask firms whether they actually comply to this, whether they're able to actually store data digitally or share data, etc. And the corporate reality is a bit sober because most companies do not meet the requirements to manage data efficiently, because product data is often still stored in an analog form. Many companies do not have a data governance, and on which this is the basis of ensuring the data quality and data integrity and data security. So there are still a lot of issues here. So looking at the graph now, you can see that only a third of the companies are fully data economy ready. There are certainly data economy in partial ways, but when it comes to all these three aspects, it's only a third. And it is, when it comes to larger companies, they're much better prepared than smaller companies. And last but not least, if we want to have a digital product passport, we need to share data. That's something I've mentioned earlier on. The Data Economy Readiness Index shows, I've taken out one question, or two questions, where we asked the companies whether they receive data or deliver data to other firms. And you can see in the graph, no data reception and no data delivery is the majority of the firms. So we're talking about the digital product passport as a political agenda issue, but we need to take, in particular, the SMEs, the smaller, medium-sized companies with us to get ready for this. They're able to do this. It's just they're not prepared for this yet, and they need to get on the way to happen, to make this. So to finish up, I just want to kind of sum up and link the policy issues with my results. And first of all, we've got very ambitious targets here, and we want to conserve resources, save resources. At the same time, we still need to stay competitive, and the economic situation at the moment is difficult. So we've got a couple of restrictions here. So we need to find the balance between competitiveness and resource conservation. To just kind of sum up what is going to happen. So we have the sustainable product policy at EU level with the eco-design, which is supported by the national circular economy strategy as well. So the aim is the promotion of circular products via public procurement. That's one aim they have. The benefit is if we make circular products as a norm, we'll have an innovation boost by redesigning materials if there are the right incentives there and products for circular use. But at the same time, industry wants to develop their own technologies, etc. And so we need no restricted competition for materials, technologies, and innovation. All difficult points. And we have to be very kind of restrictive when it comes to implementing further regulation, because we need to see that we don't have any conflicts, because we have certain regulation already in, and if we have multiple regulations, then we need to see. It doesn't look like as if the national circular economy strategy is going to have any strict targets. There's only one, that we want to reduce resource per capita consumption to 8 tons per head, but otherwise there are no kind of regulations planned. When it comes to the digital product passport, the aim is to increase market transparency, efficiency, but also, and that's the positive aspect, I think the digital product passport shouldn't be seen as a burden. It should be seen as a chance to enable new business models, because if we have all this data and all this transparency, we can analyze data in a complete new way. So this is something that needs to be stressed, because at the end of the day, who is filling out or filling in a digital product passport? It is the firm, and the firm needs to have a net benefit subject to the implementation costs. There are costs, obviously, because we have to fill in the data, but it has to be, at the end of the day, a net benefit. So, since there's no concrete proposal yet, our institute still wants an implementable, an adaptable solution, a modular solution that we can start maybe with a more modest digital product passport which can be extended. And what we need standardized collection and transfer of information. So using global open standards that companies are already using as the basis is a good prerequisite to get the companies to take part in this. Thank you very much. So I'm happy to act also as a chair for the session using digitalization for more recycling and resource efficiency. So what we're going to do now is we're going to listen to 4 joint research projects which are being funded under the funding scheme, Digital GreenTech, by the Federal Ministry of Education and Research. So each project has 5 minutes, and there is a small clock for the speakers here that counts down the 5 minutes. I think you've seen this yesterday. I wasn't here, unfortunately, yesterday. So first, I'd like to ask Kia Choré to come and present first results of SOREC, digitalization of sorting processes for fine-grained metal-containing waste streams. The floor is yours.
Hello, thanks for your warm welcoming, and thank you for everybody coming and joining us today. So, can I see the project? Yep. I tried to finish it in 5 minutes, however, it's a lot to talk about this wonderful project. So we tried to digitize one recycling machine, which is trying to separate the material. So there was some problem with the machine, which was analog, and we wanted to make it more smart, that it can recognize the problem is happening to the machine and itself fix the problem, even though when there are technicians, they are not there, or employees, they are not there, because the machine was working for 24 hours every day, so needed to be digitized and working more efficiently. So the other material we were working on that, they were being separated by the machine. So they were in the size of 1 millimeter to 4 millimeter, and they are mix of the plastic, aluminum, coppers, and where they are coming from. So these material, they are coming from the cables, from the devices, electronic devices, which were not using anymore or needed to be recycled. So they were kind of destroyed or waste electronic devices. So how we go through this process, the last machine is the machine which we are working on that, and we are digitizing it. But this material directly is not coming from this machine. It's coming from the first machine, which it's destroy the material to make it more small, that the separation can be more easy. And then go to the cutting mill, make it more small, and then the screening to make it the sizes that we wanted, and then at the end it comes on the eddy current separator, which we are working on this machine. So that's the cable, and this the second process which make it small, and then this is the machine, and the last image is what we want, to have the material more pure and more accurate. When the recycling is happening, then we can have more pure aluminum without having some plastic or copper inside. Then we can reuse them in the industry again. So the machine has some different components, which is the vibration feed, and the drum, magnetic drum, and the conveyor belt. And all these three main components of the machine, they are connected to the control unit, which is manual. So basically, technicians, they needed to be always with the machine and change the speed of these three components with the control unit, which is manual. So we try to digitize the control unit and also find out the problems. When machine can understand the problem is happening, send it to control unit, which we replaced with PLC, that PLC can come to the action and change the speed or turn off the machine, or change the action of the different of the component upon of what problem is happening. So the main part of the machine, which is the actual separation is happening, is the magnetic drum. And most of the problems also is happening in that area. For example, we wanted to know that the different speed, it will affect the separation. For example, when the drum, when it's working so fast, the separation is going to be accurate, but it might be so dangerous also, because there would be so much magnetic field, magnetic features in that area, which can make, for example, fire in case if we get iron inside the material. So the area around the magnetic, it was very important for us to see what's going on around there. So we use some sensors to find out the different speed of the vibration belt and the drum. Then we can understand in which speed we can get the best and accurate separation. So the issues would happen in the machine on the belt. For example, we never wanted to have a sharp object on the belt because it would damage the belt. Or we don't want the big object on the belt because it would disturb the separation, so the accuracy would be gone. Or also, the most important, we never wanted to have a small piece of iron on the belt, because when it goes to the drum part, it will stick on the magnetic field, and it doesn't let the other stuff goes, and the process will stop. And if, in that case, nobody's around the machine to see what's going on, because the iron is stuck on the belt, if nobody sees that, then it can make heat, and it can, at the end, fire the belt. So we try to digitize that part, because it would be very dangerous for the society, for the people, for the whole company. So the solution, we try to use the different AI models to find out what's going on, even nobody's there. So this is the image that we took with line scan camera. So the first, okay, one of the images is not clear. So the first image is the setup of the belt. So we try to put so many sensors and cameras, different kinds of cameras, above of the conveyor belt to monitor it first to see, okay, what's going on. And we use the mass-car CNN model to figure out what is the features of the materials. For example, the size, the colors, or the shape. From the different features, we could understand if the size is bigger than the size we wanted, it means that there is something big on the belt which we already defined that it should not be there. Or when we define, for example, the shape of the material, if it's sharp, we can understand we didn't want the sharp material because it's not good for the belt. So we use different cameras, like, for example, line scan camera, and since the machine is working so fast, the belt is going so fast, and there were some cameras, they were not enough good to take the image really with good resolution. So we went for line scan camera to see if the belt also is moving so fast, we can still have good images that we can train them with the model really good. So this is the line scan camera that we try to figure out the shapes and the size. This is the heating camera. We put it above of the belt near the drum area. We can understand how much is the heat. So if the heat it was more than what we wanted, we could understand something is making more heat, more temperature there. So we could understand maybe iron is there that is making heat. So also we installed the PLC above of the control unit. So they are now working with each other. So now we are trying to, this is also digital twins of the project, that at the same time we are working on the digital twin. So what we have done, so far, so the PLC installation is over, the AI model is over, the digital twins, we are trying to finish it, and we are now in the level of optimizing the AI model to make it more better till next 6 months.
Well, thank you very much. We're going to do a Q&A session at the end of the 4 presentations. I didn't say that at the beginning. So now I would like to ask Jan Kühlem from Point 8 GmbH, or Point 8 GmbH, I'm not sure. 8, yeah.
Good morning. I want to present to you the current status of the project Kimba, an AI and sensor-based quality management for construction and demolition waste recycling. Shortly, the motivation about the project, why are we doing what we do. Here you can see the construction and demolition waste stream in Germany, which is with around 220 million tons per year, the biggest waste stream we have in Germany. As you can see, most of the material is going to very low value applications, going to landfilling or just groundworks. And our goal with Kimba, we want to improve the treatment process, that more material can go into higher value applications, and thereby we can reduce the need for new material, so we can reuse the material which is already coming from tear down buildings, and we don't have to go to get new material. The setup, what we use is we have the crusher from our industry partner Klemann. You can see the crusher there at the MAV in Krefeld, another industry partner of ours, and it's already standing there, and I will go to shortly in detail. I hope you can see the bottom because there I will show you the process of the crusher. First we get the input material. As you can imagine, it varies a lot because every building is different, so you'll have a lot of variation in the input. This material, it's mainly concrete, will go into the treatment process. This is containing of the crusher chamber and some sieves or some screens, which will mainly, as you can imagine, crush the material and make it smaller. And then the important part for us, it's the output, because we want to monitor the output, because the particle size of the output is a very, very important parameter for the use of material in higher value applications. So if we can monitor the output and improve the output, we can also make this material available, for example, concrete aggregates. How do we do this? We have a sensor system that is monitoring the output material, and with this, we can monitor the output, and also together with machine data, we will process this data together. So we'll have neural networks, which are I'll explain to you a little bit later, and also machine data. And with this together combined, we'll give recommendations for the operator to get the best output out of the current input, so we can have a kind of live system which is improving the process to get the best output and the output we need to use the material. Okay. Yeah, where are we at right now? At the ANTS in Aachen. There is this laboratory scale experiments that these we can use to create data, because we have a 3D LT camera and also line sensor for the analyzing the material on the belt, and also we can do the calibrations there and create example data or sample data for the training of the neural networks. Another step we are at right now is the creating a simulation for the impact crusher, which is basically a digital twin of the material flow. And with this, we can determine unknown parameters in the machine, because we don't get all the parameters we want out of the data, out of the machine data. So we need to simulate to get a better understanding what's happening in there. And we'll also optimize the simulation with the real process data we get from example runs, the MRV. Okay, another focus is the image segmentation, where the DFKI in Kaiserslautern is working on. And you can see at the left, that's sample input data. And if you use a segmentation to get a default with the default model, which is available, you can see that it's not very good at detecting all the particles we need or we see on the belt. So we definitely need to get better, and that's what the DFKI has already been working on. And on the right, you see the developed model, and you can see that we can detect most of the particles in these images, which is the first step of the classification of the output, because in the end, we want to know which material is on the belt at the output. Yes, that's the current state in this. Additionally, we did stakeholder workshops together with the EPAM, another partner in Siegen, from the University of Siegen. And there we work together with the industry to identify the needs, so we don't develop something that's cannot be used by the industry. Also, we can derive additional project requirements and identify obstacles and blockers, because as you can imagine, in the building industry, there's lots about norms and things, and there we have to get all the stakeholders into one table, also external stakeholders, to work with them and identify where maybe changes are needed, where we can use this material better. Also, we can address non-technical aspects, also one part of our research. And yeah, I thank you for your attention and look forward for the questions in the Q&A.
Thank you very much. Now, Dr. Sven Gleich from Vitesco Technologies is going to present us something about the REDUCE project, which is resource-efficient production through human-centered measures. I'm intrigued.
Dear ladies and gentlemen, before I begin, I would to thank you, Dr. Nilligan, for your excellent keynote, actually, because it's somehow supporting the experience which we also face in industrial production. I can tell you, we start to save energy and resources, but as you mentioned, basically most of the people, they do not know how much do they consume. They just use it and they have no idea how much energy actually is used. All right. In our research approach, we want to combine a technical, digital, and human-centered approach to support humans on the shop floor act resource efficient. Therefore, there are several partners, you have seen them already maybe on the slide, and our aim is to develop a human-centered energy management and information system. I will now tell you the step where we are, or the steps where we are, and give you at the end some outlook. The end user in our case is an automotive supplier. It's with a highly specialized serials production. There is a vast of manufacturing processes from assembly, welding, cleaning processes, also cutting tools, and so on. The average energy consumption per year is 35 megawatt hours. And when we were in search for a pilot area, this is a quite huge plant, we were led by the three questions. Do we have an alternating production there? Do we have manual operator activities? That means, are they influencing somehow the production? Do they have the chance to? And finally, do we have equipment there which is in a similar way existing in other areas? So we have also the chance to transfer our results. The first or one of the first pillars is that we have to acquire data. Data acquisition is one of the main parts, and therefore we used an own developed device, which may be the most important key aspect is that it can send the data directly to the cloud, where we then do the further processing. We have several stages then in the cloud processing itself. It's the management of the devices. It's also collecting the energy data, fluid data, gases, natural gas, and so on, what we consume. Finally, apply a business logic, so-called lambda functions, and at the end, the storage of the data itself in data buckets to make them centrally available. Now let's have a short look on the pilot area. This, what you see here is a testing line. The onload, this is at the bottom. There is usually a human interacting with the line itself. It's feeding injectors on the line, and then we have 4 testing stations, station 50 to 80, which are doing the 100% injector test. Every module has a peak energy consumption of 18 kilowatts. And overall, we have currently installed 16 sensors at this line. And the data then is available for further visualization and operation. What we figured out so far is that we have an energy consumption approximately between 500 and 1,200 kilowatt hours per 1,000 pieces produced. In parallel to our data activities, we had also a comprehensive work at the shop floor describing the process itself. We therefore used interviews with the persons which are working there. We had focus groups interviews. We have a description of the process from the standards itself. And finally, this led us to the ability design a conceptual model, which its main part is a so-called decision tree. By using this, we give the people the possibility to act according to our needs, in this case, to be resource efficient. Now we are at the point where we have on one hand data, and on the other hand we have a model itself. So now we want to combine them and also bring it to the people itself, to the humans, which are in the center of our project. So therefore we need somehow a visualization. We used a framework, and by using so-called narrative design tools, we transferred this data into a user perspective to see different role models and how they receive or achieve the data and how they can then react getting the data themselves. That means we created several user journeys. What you see here is only a small excerpt, and I would like to invite you to the poster session afterwards if you're interested in more details in that process. So now let me give you an outlook and some of the potential we already identified. The pilot area is in the blue square, which you see here, consisting of this testing line, which I already was describing. There are 4 stations, and we have around this area in the yellow or orange rectangles additional 25 stations which have a similar equipment. That means we can probably apply also approach on that lines. You see already here that we have a saving potential identified of 6.8 tons CO2 equivalents per line, which is quite a lot in this context. And the next steps will be that we align with the shop floor and the technicians about switch on and off conditions. Finally, also implement the visualization on the shop floor. And then we are able, after those 2 steps, to evaluate our solution and do also assessment of the transferability, which mentioned at the beginning. I would like to thank you, BMBF, supporting our research work, and also thank you for your attention today.
So our final talk is going to talk about compost, which is the moderator's favorite topic again. So Nico Domerat from Fraunhofer Gesellschaft zur Förderung der angewandten Forschung is going to talk about the project DigiCompost, development of a decentralized IoT sensor system for AI-supported management of composting plants. Thank you. The floor is yours.
Good morning, everybody. It's my pleasure to take you by the hand and show you what we've developed during the course of the last year in DigiCompost. DigiCompost, nomen est omen. We are the digitizing compost hives and heaps, but not the compost that you might have in mind in your backyard. It's more commercial compost facilities. And the challenge here is that actually there's no obligation to digitize this project or this kind of facility yet. But due to the fact that decomposting is a process of biology and breaking down materials, there is a significant greenhouse gas emission potential, which can be reduced or moderated by properly timed interventions. But in order to do so, you have to have data in hand to have a glimpse what is happening in the biological process. So to make it easier for you to understand, there is a big pile of organic material which is usually composted, as you know it from your backyard. And currently the facilities are only obliged to keep records about the materials that go in the process and the materials and the quality that comes out of the process, plus some temperature data to ensure that the materials are properly hygienized. Most of the time the facilities are quite remote, which means that usually they barely have access to digital infrastructure, which is a challenge for us to bring the data into the cloud to allow the AI to do something for us. So the first thing that we did is basically do a macro approach. So in the end, we want to develop a lens that is very easy to inject it into the compost hive. But as a first approach, we started to do the macro approach. So we gained our own data. So we have data, real-time and real-life data, which is already connected to the digital infrastructure. So over there, you can see that we are already shooting data packages into the cloud. So the first bottleneck is solved, and so the second one is to be tackled. So after having something that is rather huge, lab-like setup, we have to build our own hardware, which means that we have a prototype lens that is now ready to be injected into compost hive. That's a rather tough environment, so it's hot, there are a lot of organic acids, and you need a strong person to push the lens into it, because the total length of the lens is approximately 2 meters. So you can do that by a lot of muscle force, or you can do that by speed, of course. So there's a lot of mechanical stress to the lens, but we also managed to have a lens that has a miniaturized temperature sensors, gas analyzing tools, plus some electronics, power supplies, and some data mining tools that basically create the data packages to be sent into the cloud. And yeah, what we are now trying to develop and to make it a system that is now actually doing something for us is the data aggregation and modeling tool. Here you can see that there is a certain structure and process already given, but this is basically an outlook of what we are aiming for the next year. So thank you very much, and I'm happy to get your questions afterwards.
I'd like to ask all the other speakers to come up and sit with me. So we've heard about 4 really interesting projects. Being an economist and using usually just data and statistics, I thought it was really interesting to see all these photos showing real products, real materials. So thank you very much. Are there any questions? So we have Sorek, Kimba, Reduce, and Digi-Compost. Yes, it's a microphone coming.
It's on? I don't know. Yeah. As I learned yesterday in the afternoon workshop that it's very important for non-technical people to understand how you work together, so like the team building, and also how AIs work. So how do you already incorporate this into your projects?
Well, it's for anybody, I think, who's using AI. Yeah, exactly. Who wants to start?
No issue. First of all, we are probably one of the projects which does not use AI in our context. But of course, we are working together. We are using several tools to collaborate. And since we are also at different towns located, we mostly use, and for our data, which we acquire on the shop floor, we have to use, like mostly people do here, the cloud access. We using in the devices which I have shown, they are not sending this data in a source format. They are using certificates on the device saved to then scramble, or let's say to cipher the transaction. I don't know if this is answering your question, but concerning yesterday, I was also attending the workshop, and we were talking about data security and so on. Those measures are already, in our case, implemented, since we know, maybe some of you have heard that somebody said, data is the new oil. So this is very important for us to make this data safe, and to keep it, and to take appropriate measures.
Yeah, I think about collaborating, because we also work in different cities. In the project, we have our project meetings regularly, and I think it's also important that you also meet in smaller groups, discussing more into detail what you want, what the next steps are, or exactly on specific topics, and there go very into detail, into planning, what are the how to exchange data, what's the formats, and we have to go work together regularly and very into detail, that not one party is producing something that the other can't use. So I think that's how we do, and also we have the project meetings regularly where we meet in person. Yeah, and for explainable AI, I think we also won't use very, very sophisticated, very complex models, but we use specifically AI, for example, for image segmentation. So this is a smaller part of the project and not like for everything. And there you can definitely control or check if the AI is doing the right thing with test data and all this. So I think there we can understand quite good what the AI is doing and control it.
Yes, and also our plan basically from the first day was to use AI, because recycling, especially in material like aluminum, copper, is not really healthy for people who are working there. So the plan completely was to digitize it, not to reduce the people who are working there, not to just make it more healthy and efficient. And also the data we are producing, that was a really interesting and specific custom data that it was not exist at all in Google, for example. So we wanted to produce our own data that later other people, they can also adopt this data and just use it in other projects if they want, or if they want to improve this our project for more level it up in next some years, they can have the basic data that we already produce for them. Yeah.
Are there any other questions?
I have a question. Can you turn on my Microphone, yeah. Thank you very much. Dr. Missa from the Federal Ministry of Education and Research and Education suggested yesterday that you should imagine to be in an elevator pitch when you might meet a decision maker. So could you please do an elevator pitch and don't tell about what you're doing, but what's the impact of your research project? That's a journalistic question so far. I'm sorry for that, but I think it's it helps probably to understand more what's the impact of your research project in the end.
Who wants to start?
I can start. I think it's easy for me because it's the first slide of my presentation. Basically, as you saw, that most of the material is just dumped somewhere, and you need new material to build new buildings. And our goal is that you don't have to use new material, it's endless resource. So with our project we can reuse the material that's already there, and just by improving the process of treatment we can then reuse this and build new buildings from this scrap material.
All right, in an elevator pitch I would probably tell the manager, then when our project is finished, then you will be able to go to the shop floor and ask anybody at the shop floor and ask them about energy consumption and reduction, and they give you a concrete answer based on figures.
DigiCompost is helping to reduce greenhouse gas emissions from biological decomposting processes.
So for us, basically it was to reduce the expenses and use them again in the industry. But my personal opinion about this project was always thinking about make it more safe for people who are working there, because most of us, when we are living in the society, we are not seeing that part of the industry that who are working there. So the air or the noise or the dust, so because it's not our everyday working there, so that part of the industry, I guess, is hidden from the rest of us. So the plan, of course, it was to save the resources and reuse them and reduce the expenses and make it more cheap. But my personal idea, it's always thinking about, aside of that, I have to first think of how to save people's life, because all of us, we are the same. So everybody has some family. So for me, it was very important to make this machine digitized and make it more efficient for everybody, for everything.
Yeah. Thank you.
That was a very long elevator.
It was a high building.
A very high building. But so interesting.
There was another question here.
So it's also a question for all of you. What's your lesson learned from your first year? Maybe what's something that did not work out the way you planned, or something you would tell somebody starting a same project, some similar project, to plan differently?
What I would do in another project probably is to start involving people earlier, which are necessary for the project. Not only the partners itself, of course, but in our case we have quite a huge production floor, and as earlier you start to involve people there, since you need them, in our case, to act, to acquire data and so on, IT department and other people in the production floor, the more chance you have, first, fulfill your plan, and secondly, you have more time to convince them what you do. Because usually they, I wouldn't say they are not interested, but usually their daily task is another one. So you have somehow to try to convince them, please support me, please help us, and make your part of the project.
I think for me it would be even more communication, or also, although we did a lot of talking what we want to do and how we do it, because we all come from kind of different worlds. If you imagine a recycling facility versus a data science company, it's very different. So we have to align on a lot of things. For example, yesterday I gave that example with in the sessions with Microsoft and Linux, that the camera we bought is only, or we can use, can only be used on Windows, and we wanted to program on Linux, and so we have to align. We can solve it, but still that things that came up because of the different contexts each company is in. And I think it's very good for learning too, because everyone will learn and see the sides of each field, which is quite good. But it would have been faster if you communicate even more and understand that there's so much differences.
I do agree with both of you, because yes, communication, and also I would say I would also integrate people more early, because when we wanted to use AI, for example, first we needed to know the machine very well, so we needed to communicate with the technician, with that part of industry first, to see how is this machine first is working, and now we want to make it digital, or we want to make the digital twins of that. So first, before bringing AI and technology and IT, we need first to go to that industry and talk to those people. And also, I also learned in this project, when it starts, maybe before writing the proposal, we need to already write email or for ordering the equipment, because it take quite a long time. That when you order equipment, like for example, likeness and camera, it took around 6 months to reach to us. So it's, I guess we need to think about the equipment very, very early, that we can make everything on time, that we don't have to run, and it takes a bit, us in the challenging. So, yes.
Things that work good for us, we have the comfortable situation that we have a product-based development. So you can do the salami tactic, slice it down, give roles to everybody. It's being showed 1 year, we have an MVP, that's super good, works well. Maybe learning is not so much for me, because I'm a horticulturalist. For me it was clear. But for the data people, that it's a biological process, and there are a lot of unknown parameters, and that's quite challenging. But again, since we developed this nice salami and rolls, it's very easy that each and every partner informs the others and communicates, okay, what is going to happen, how can we conquer the situation, and how can we fill the gaps.
Are there any other questions? The microphone, please, here.
Thank you so much. I've got a follow-up question for DigiCompost, because you mentioned CO2 emission reduction. Did you already make a first estimation how large that would be per site, and maybe also for whole Germany, if your approach is being taken over in all of the sites in the country? Thank you.
You found a weak spot, because we have a product-based development with an ambitionistic time frame. That means that we went for the low-hanging fruits. So you have different kind of composting facilities, and we went for the nicest material metrics that you can have, which is green clippings. So there is not so much emissions to be expected, but it's also a nicer environment for the sensor, and you don't have so much hickories, so to say, in the process. But now that we have a sensor that is tough enough to conquer also matrices, other matrices like the Specki toner, we will definitely see that there is situations where there is simply not enough oxygen in the process, and then you not only have CO2 emissions, we will also see methane, which is even a tougher nut to crack. So the main focus that we have now is to identify tipping points in the process, so to be able to give you an alert on your mobile that there might, with the forecast of the weather and the compostation process, that there might be anaerobic environment in between the next 3 to 5 years. So it's now the time to do a mechanical intervention to bring oxygen into the process, and then we can see, okay, what happens if you get the alert, and what happens if you would do business as usual, and then we will see the gap and can answer your question precisely.
I think there's a follow-up
remark on that. We would be happy to support you in first calculations because, as you know, as part of the Net Digital GreenTech project, we will be doing the self-evaluation of potentials for savings. In that respect, you can count on our support as Öko-Institut.
Awesome. We should play cards afterwards.
Yeah.
I think this is the main aim of such a meeting, networking and talking about what you're doing. I think it's really interesting that you're actually mentioning the human centrism, that we are not only just doing AI and getting rid of people, but that we need people and society to get in. And I have a question. Do you think you've gotten that it is for society an acceptable project or aim you're targeting very often when it comes, you know, you're saying you're far away from everybody, like your pictures showed you, the institution is far away from the village, etc. So is this an issue in one of your projects, that you have a lack of acceptance, whether it is for employees or for society in general?
I have the microphone, so I will just keep it. Yes and no, because we are hiding in the bushes, so nobody sees actually the AI working. But the companies that do the compostation processes are a little bit afraid of being transparent, because they know that they have greenhouse gas emissions, and they are a little bit afraid to show that there might be an authority that give them the obligation to show them the numbers behind. That's the only thing that we have. Other than that, everybody sees it as a very nice tool to work with.
Okay.
Like unusual battle for microphones heard today. Well, we faced actually both aspects. We have people which are convinced by what we are doing, but we also have people that say, well, why should I save resource and energy? It's not my money. I'm just working here, and if I save energy or not, it does not pay out for me. I get the same salary every month. So this is what are also harder not to crack for us, to convince people that also not at your home where you see it probably every month how much you consume, then you have to pay, but also on company level that we are like also supporting this initiative, because the industrial sector is a big, we use a big amount of energy actually. So that's why we also have to take measures to reduce it and to show them to the people too which are working there.
Thank you.
Yeah, not an answer directly to a question, because I think most people don't think about what's happening if a building is demolished and then what's happening with the material. I think that's nothing that's really concerning society as a whole. But what's really interesting, or maybe some are, but I think most, yeah. But what's really interesting was if you get the people who are working in this industry on one table, was really interesting, because where we had a stakeholder meeting and you saw that if you get the people, all the one who's demolishing the building, the one who's getting the buying then the material, the one who's recycling, and then the one who's building or creating new material, there you saw that if you get them on a table, you find solutions that none of the single actors or stakeholders would be able to do. And that was a really interesting insight. If you just get them together and see like, oh, there's a really big and seamless for every single person, like it seems impossible to solve this problem, but as soon as you get them to one table and discuss, you see that solutions emerge, and there's one person saying, yeah, if you would do this, then I could use this material better, and the person saying, yeah, that's easy, it's simple for me. And that was, I think, a very good or cool thing to see, that our project is relevant for this industry and for the people that work with these materials. Yes.
Thank you. Yes. For me, the experience I had with the machine, because I was the one who was actually working with the machine every day. So there were two technicians, and they were always helping me. So there was nobody actually to give me the negative feedback that we don't want this, or this is not a good technology. But interesting was they didn't know what is the technology about. So I had to let them know, okay, we are doing this, it's gonna happen like this. So, and they were like, so it can happen that the belt will be digitized, or or the ROM will be like this. So they didn't know about the technology, but when I let them know, they didn't have any negative expression about this technology. However, I can also say when the AI come to the picture, still the technicians, they are going to be needed always there. So AI, it's making it smart, but human, they have memory. So technicians, they know still more than the AI. So it's not going to be reduced.
Well, thank you very much. I think this is a good way to finish up this round, that AI is going to be part of our kind of new processes and our way of manufacturing and recycling, etc. But we still need the people. Thank you very much. Thank you very much for getting up so early.
Thank you very much for introducing us to your projects. We learned about 14 research projects from the BMBF research funding measure, Digital GreenTech, and it was really interesting. And you have time to mingle and to network now with your posters in the coffee break. I think the posters will be there the whole day, so there's opportunity to get to know and to discuss your project. Thank you very much for listening. We have a coffee break now and meet here again at 10 past 10. So have a good coffee break.